Bangalore?
That's right.
Kennedy, yeah. Okay. By any chance, had an opportunity to see Vishweshwaraya Museum?
No, I've heard about it, haven't been there yet.
I think you should do one, find some time, because right now, of course, it's COVID times, but once the museum is open, please do find some time.
Sure.
What we'll do is we'll connect you with the director there. Maybe, I'm sure we can do something for the Google family also.
Thanks.
Because when I was in Delhi, we had done one thing with the PCS. The family members, they came to the science center as volunteers on Saturday and Sunday. It's very successful. Yeah.
Sir, you are muted.
You're muted.
You are muted, sir.
You're on mute.
Manas, you are on mute.
Am I audible, sir, now?
Yes, sir.
Yeah.
Okay, so we are going on here. On behalf of Regional Science Center Bhopal and Regional Science Center and Planetarium Calicut, a very warm welcome and good afternoon, all friends. We are on our online channel, the RSCP Calicut virtual and Facebook Live of the Regional Science Center Bhopal. We are very happy to declare that it is the first occasion where two of our centers are collaborating to organize a webinar online. Actually, today is an important day for us as well. In the future of India lies the future of a sixth of the world's population. As the artificial intelligence is becoming a revolution and it is sweeping through the societies and the entire daily lives everywhere, its role in shaping India's development and growth is also becoming substantial. So for India, AI holds promises as a catalyst to accelerate progress, we hope. And that is why we thought that we should look into the AI scenario for India. And we are so very much happy that with us today, our special expert guest is Dr. Manish Gupta, and who is known to be a global technology leader. And welcome, Dr. Gupta, to our program, and thank you very much for accepting our invitation. I'll just give a brief biodata of Dr. Gupta. Dr. Gupta is the director of Google Research India. He holds an additional appointment as Infosys Foundation Chair Professor at IIT Bangalore. Previously, Dr. Gupta has led a video technology startup and the research centers for Xerox and IBM in India. As a senior manager at the IBM T.J. Watson Research Center in Yorktown Heights, New York, he led the team developing system software for the Blue Gen supercomputer. IBM was awarded a National Medal of Technology and Innovation for Blue Gen. Dr. Gupta holds a PhD in computer science from the University of Illinois at Urbana-Champaign. He has co-authored about 75 papers with more than 7,000 citations in Google Scholar and has been granted 19 US patents. Dr. Manish Gupta is a fellow of ACM and the Indian National Academy of Engineers. He is a recipient of Distinguished Alumnus Award from IIT Delhi. And there cannot be any better person than him to talk about the prospects and situations, scenarios regarding IT in India and their research in AI, particularly in Google Research India. Welcome, sir, and the stage is all yours, sir.
Thanks, Mr. Bhakti. Okay, so it's a pleasure to talk about again the work that we are doing for AI for India and beyond. So I'll start with again, we can see all around us computing in general and artificial intelligence in particular, right, is beginning to change the face of everything around us. It is impacting each and every industry. We have seen in the middle there is a photo of a car, of an automobile factory, where now on the factory floor you find very few humans around anymore, because most of the work is being done by robots on these for car manufacturing. Now on the left, top left, you see again a self-driving car. There are self-driving cars which are beginning to appear in certain cities in the world. And if you think about what all a self-driving car needs to do, right? Kind of sense its whole environment around us, around it, and respond in real time to, again, any kind of situation, right? For instance, somebody coming in front of the car and so on, do that all automatically. You can, again, imagine, right? The kind of capabilities it takes to get these cars to work. Of course, these cars would not work in Indian conditions, but at some point, yes, self-driving cars will work even in Indian conditions. And the Indian IT services industry has also been applying AI to transform itself. There is this whole term called robotic process automation. So a lot of the work that is done to, for instance, deal with queries from customers or manage various IT systems and so on, a lot of the many parts of that work are now getting automated, right, through again the application of AI. So one of the questions is kind of, is there anything special about today? Because I mean, you can imagine, you can say that, look, technology has been advancing for now several decades now. Is there anything really special about today's times? And I would argue, yes, there is something special about today's time in computing, overall history. And to kind of make that argument, I'll draw this analogy from this story that at least I used to hear when I was growing up as a child, and hopefully many of you have heard the story as well. There are various versions of the story, right? Some famous chess player who pleased the king, and the king asked, "What reward do you want?" And he pointed to the chessboard and said, "Okay, give me 1 grain of rice for the first square, double the grains of rice for the next square, and so on, and keep doubling, and just give me enough for the chessboard." And the king said, "Is that all you want?" And he said, "Yes." And so as the king kind of ordered kind of this person's wish to be fulfilled, he realized that he would not be able to honor that promise and give him enough grains for the chessboard. And at what point did the king realize that he would not be able to honor the promise? Not when you were at the first or second squares, when you got to the middle of the chessboard. Because this power of exponentiation, right, is something that all of us it's very hard for us to like fully grasp the power of exponentiation, right? We are much more used to linear patterns, things kind of adding in kind of constant quantities, but when they multiply, it's kind of hard for us to grasp, right? And we are, for instance, right, we see ourselves dealing with that as we see the COVID numbers kind of rapidly going up exponentially over a period of a few weeks. So I think what I'm arguing is something very analogous is going on with the world of computing, right? Analogous to this grains of rice. And that analogous thing is what I would say, look at Moore's law. So I don't know how many of you have heard of Moore's law, but it's okay if you haven't, because it's not a real law, like a real law of physics, like Newton's laws of motion or anything like that. It's more of an observation that was made by Gordon Moore. So Gordon Moore, who later on became one of the co-founders of Intel Corporations, he made that prediction in the year 1965 in a paper where he predicted that you would be able to double the number of transistors that are packed in a given integrated circuit, in a given chip, with every new generation. And it became kind of, the industry made his prediction kind of come true. So for the past like over 5 decades, we've enjoyed those roughly every 18 months, we've enjoyed that doubling of the number of transistors. And with that doubling of number of transistors, roughly the compute power of these chips has been growing. In fact, I was told in the year 2006, when I was giving a talk, I just returned from the US and I was giving a talk for IBM. Somebody passed on this factoid to me that this year we are going to produce as humanity more transistors than grains of rice. So already in 2006, with this, all these exponential advances in powered by Moore's law, we were already producing more transistors than grains of rice. So this analogy with the chessboard and the doubling of grains of rice on the chessboard is very apt. That I would argue that around the year 2006, we reached that kind of equivalent of the middle of the chessboard, where computing power became so high that things that we previously thought were kind of impossible or infeasible computationally, those things became possible. So, and of course, since then, while Moore's law is now slowing down, we have continued to have those further exponential advances in computing power. So today, we, as humans, we produce a lot more transistors, in fact, than grains of rice. So what has that computing power allowed us to do? One of the things it has led to is this whole revival of, in a sense, this whole field of artificial intelligence. I mean, it's now back front and central, because AI is a very old field, pretty much as old as computing itself. And there was a particular technology called artificial neural networks, which the computing community kind of gave up on in the 80s, because they weren't really able to kind of really solve interesting enough problems, despite the initial promise. But now, with that increased computing power, that same artificial neural networks has made a comeback as a technology, and now it's called deep learning. So I'm sure many people in the audience would have at least heard the term deep learning, because it has become a big buzzword about how to solve problems, again, using, it's a particular form of machine learning, which in particular is a particular field within artificial intelligence. But deep learning has pretty much become like the dominant almost methodology within artificial intelligence. So what it does, I mean, I'll give a very simple explanation and simple introduction to what deep learning does and artificial neural networks. Essentially, you take very simple mathematical units. So a single mathematical unit might do something no more complicated than take your input, multiply the input by some weight, let's say some fixed weight, it could be between 0 and 1, and then add another number to that input, and then pass on the output. And so when you organize these very, very simple mathematical units in layers, what the researchers behind artificial neural networks have shown is that you can do some very, very interesting things with that layered network of these mathematical units. So as an example, if you feed it the image of a cat, right? So the image is represented in the form of various pixels. So you feed all these pixel values to this artificial neural network. All those pixel values kind of get manipulated upon, right? So a unit will take a few pixel values, kind of multiply them by some number, add some number, and so on, and pass on to the next layer. And again, in the next layer, you can also do operations like you take the maximum of the inputs that you're receiving and so on. So you do these very, very simple mathematical operations in these different layers, which are shown in this figure. And at the end, out comes a function. It could be like a classification function, right? Where you're choosing one of, let's say, 1,000 categories. You're trying to, let's say, identify which kind of an object or which kind of an animal this is. And let's say you have an encoding that animal number 2 represents cat. So out will come the function value number 2 representing the cat out of all these operations that you have done. So you have this deep neural network which is able to learn these very, very interesting functions. And what kind of functions can you learn, right? So one, which I've just given an example for, is given the pixel, you can identify what kind of an object that is, what's in that picture. So for instance here, saying that it's a hussar monkey, that's a function, right, that you can make this deep neural network learn. And this functionality is referred to as image classification, that you're classifying the image among these different categories of dominant objects. You can likewise feed this neural network an audio signal, and it could learn the output, something like how cold is it outside, right? So this is the text corresponding to the audio. So this is known as speech recognition problem, that given the speech audio signal, you can actually identify the text corresponding to that speech. Another example, you can feed it that text on the left, hello, how are you? And get the as the output, the text on the right side, which you can see is a translation of the text from English to French. So this is again known as machine translation, again, which has been made possible through, and I mean, it has been possible through other techniques too, but it has been really revolutionized using deep neural networks. And finally, final example, given a photograph like the one on the left, you could learn actually a function that describes that image, similar to how a human would. So an artificial neural network could now be given that image coming out with this output, a blue and yellow train traveling down the tracks, which is, again, a caption that it has learned along the lines of how a human might describe that particular image. So these are, again, fueled by all this growing compute power. We have, again, deep neural networks which are able to do such things. I'll also caution that, I mean, while on one hand there are like amazing capabilities that these deep neural networks have shown, there are still a lot of challenges that are still outstanding. One example of a challenge that's still there is that often we don't understand how is it that the deep neural network really came out with the output. So the explainability is often very hard. And explainability becomes very important in certain domains. For instance, in healthcare domain, if you, again, feed that deep neural network an image, and you have to now classify that image, is that, let's say, the image of a tumor, is that a benign or a malignant tumor? Is there cancer? You would, instead of only kind of providing that whatever prediction, the doctors would ideally like to see some explanation, right, of why the system thought this is a case of cancer, right? And can you identify where that cancer is and so on? And the reason explainability is important is also because, I mean, these neural networks are not perfect, right? They will also make mistakes. So how do you identify situations where they're making mistakes? So again, there are challenges because unlike humans, where typically as humans, if somebody asks me a question and I don't know the answer, even if I pretend I know the answer and say something, deep inside I know that I don't know. Whereas deep neural networks, I mean, you feed them input, they will kind of give you an answer, and that answer could be wrong. And the deep neural network, right, may still be very confident in those answers when you try to estimate the certainty of that model. So that's kind of a quick introduction to, again, AI, deep learning, and some of the capabilities that these AI and deep learning systems have today. So now let me switch gears and talk about, again, as Google Research established its youngest research lab in India last September, what are we doing at the Google Research Lab in India? So as our kind of a mission, we really decided that we will focus a lot on problems that are arising in the Indian context, but which need not be restricted just to India alone. So there could be global problems, but we start with looking at them from the context of India and look at how do we apply, again, some of our research to come up with effective solutions to these problems and hopefully, right, have an impact on the world around us. So I'll give, again, in the rest of this webinar, I'll give a few examples of the kind of work that we have initiated in these different kind of categories that we often track of work that we do that may not be tied to any existing Google product, things that where we work with Google products which are being used by millions of people in India, and also some more fundamental research. So let me first just do a quick check. I hope the voice and everything is audible and you're able to see the slides and everything. Okay. I assume, yeah. Okay. So let's start with one key area which is very dear to my heart, which is transforming healthcare.
Your presentation slide is not visible.
Oh, is it?
Yeah.
Visible. It's visible.
Your presentation slide is not visible.
Sir, visit.
Is it not visible to what, a few people or
Sir, visible,
most of
sir.
the people?
Yes, the slides are visible.
It's visible, sir.
Okay. Okay.
Okay.
Okay. So I'm on this slide, transforming healthcare, and again, my belief is that AI is going to be used in a very, very significant manner to really completely transform eventually how healthcare gets delivered. And the reason I would say I have that belief is, first of all, there's a huge need to transform the healthcare system. So what I would argue is there's not a single country on the planet which is happy with its healthcare system. And let's look at a few examples. So this slide lists the per capita expenditure on healthcare. And it shows US in the #1 spot. So this data is a bit old. This is from 2018, but the trends are still valid. So the US spends over $10,000 on an average on the healthcare of an average person each year. So this is now not how much you are spending if you fall sick. That yes, then you're spending $10,000. This is how much you're spending on an average. So this is a very high number, and the US realizes that this is unsustainable. It cannot afford to keep spending and this number continues to grow at that scale anymore. So then you look at a country like UK, where the spending is much lower on an average, and in fact, by some metric, UK actually, in fact, has higher average life expectancy than the US. You might argue that, oh, it's only the US system which is messed up. You look at a country like UK and kind of, and you will be in good shape if you adopt the kind of healthcare system that UK has. But even UK, the National Health Service over there, which delivers healthcare in a nationalized manner, it is very concerned about the rapidly rising costs of healthcare. So US, UK, all of these countries, they're trying to figure out how do they reduce the cost of healthcare while improving quality, right? Because when it comes to healthcare, nobody wants to make compromises with the quality. Now, there's one country here on this slide which doesn't seem to have that problem of a huge average healthcare cost per person, and that's India, right? So somebody who's not familiar with India, I mean, you look at our small number, $209 from, and it has grown marginally. And you might think that somebody might think that India is doing something great in healthcare. Whereas those of us who are based in India know that the reason this number is so low is because we don't provide decent healthcare to much of our population, right? So when you divide that total healthcare spent by 1.3 or whatever, 1.4 billion people, it becomes a small number. But as India begins to provide healthcare, right, to people, for instance, in rural areas who do not have decent healthcare today, we simply cannot, I mean, this slide also shows that we simply cannot afford to take the path of countries like the US. If they could not afford their US healthcare system, there's no way India can afford that kind of a healthcare system. Because, I mean, if we were to multiply our population by $10,000, we get to a number like over $10 trillion, which is much higher than our entire GDP, right? So obviously, it is not feasible for us to sustain such high healthcare spend. So we have to do something. So India must do something different. So what is that different thing that we must do? So here I'm arguing that there are two elements to how healthcare needs to be transformed. One element is that it needs to become more consumer-centric instead of being very provider. So today it's very provider-centric. Doctor is at kind of at the center of the whole healthcare system, and I'm arguing that patient needs to become kind of the key point in the healthcare system. And in fact, there have been books written on this upcoming phenomenon. There's a book by called "The Patient Will See You Now," right? Instead of "The Doctor Will See You Now," it talks about how the healthcare system really needs to transform itself to become more consumer-centric. The other aspect of the transformation, and very concretely, one of the ways in which you become consumer-centric, for instance, is that you make consumers pay for health coverage, but then you take care of the health of that consumer, right? Regardless of what their condition is, regardless of whatever, what kind of treatment they need, right? Then it's for you to provide that treatment, given a certain fixed cost of healthcare coverage, because that would incentivize you as the healthcare system to actually improve the quality of healthcare while reducing costs. Because otherwise, if the patient is paying for each and every treatment separately, then there's an inherent incentive, right, to use more expensive treatment. So the other part that needs healthcare more proactive, and the healthcare system itself is built in all these different tiers. And this was illustrated by a doctor famously at a conference where he asked this question: where do you find the most expensive place to stay overnight? And the immediate thought that comes to our minds usually, right, when you hear that question, is some fancy hotel, some resort in an exotic location. And he said, well, it's the ICU of a typical hospital, where you will, in a country like the US, you will spend over $10,000 to spend that night in the ICU. And it's not a particularly fun place to spend that night. So much more expensive than a hotel room. So his point was that you really need to ideally treat the person well before they enter the ICU, because A, it will lead to lower cost, B, it is better for the patient, right, if they don't turn so serious that they have to be treated in the ICU. So that same argument applies all the way to the secondary and then the primary tier of healthcare, and then even further. And in fact, my prediction is that the real future of healthcare, the real action in healthcare in the future, will be outside the hospital. Before you get to the hospital, what do you do at when you're living your normal lives at home and at work. So, for instance, I mean, my message to uh, I was told there are a lot of students in the audience who are listening to this. My message to the students, let's say if you're looking to do something, let's say a startup in the healthcare space, uh, focus on wellness, focus on taking care of people while they are living their normal lives before they get to the hospital. Because if you can take care of people uh, in a proactive manner uh, and encourage them to adopt a healthier lifestyle, take care of any kind of a health issue uh, in a proactive manner, that leads to much better outcome for the person and also lowers the cost, right? So there's a saying that prevention is better than cure. So uh, exactly that same argument. And to show now how AI might be used, right, to enable this kind of a transformation, right, to enable more proactive care, let me give two examples. So one is an example of screening for diabetic retinopathy. And diabetic retinopathy is a growing cause of blindness. So there are over 400 million people in the world who are affected by diabetes, and they are potentially susceptible at risk for this problem of diabetic retinopathy, which can lead to blindness. So the key to preventing this blindness is regular screening, right? So that's the common theme. If you can catch these problems early, then you can have better outcome. So screening is the key to preventing blindness. But what happens in India is, again, there's a severe shortage of eye doctors. So what happens is 45% of the patients, they end up suffering a vision loss before they are ever diagnosed with this condition. So again, and once you have already suffered a vision loss, right, it's kind of, it's too late, right? It's so much better if you could catch the person while they still had their eyesight fully intact. So how do you do that screening? So the way it is done kind of by experts is that you take these images of the eye through a special camera, the retinal fundus camera, and you take that image of that retinal region, and the doctor usually looks for signs of hemorrhage in that image. And based on that, they diagnose the condition on this 5-point scale. 1 would be no diabetic retinopathy, and 5 would be very proliferative, extreme form of diabetic retinopathy, serious condition. So what we did was, I had earlier talked about how deep learning system, right, can recognize from an image, is this the image of a cat or a dog, right? So there was this whole deep learning architecture that was developed, and in particular, an architecture called Inception 4 to do this image classification task. So our team built up on that work and adapted this to now start rating these images, right, on this 5-point scale. Is this a case of no diabetic retinopathy, or is there a mild case, or a moderate, or a severe, or a proliferative case? So our team kind of did this work, and again, I mean, I'll skip through a lot of details. They went through a lot of years of work to improve these models, and eventually they got to a point where, and they published this work in the Journal of American Medical Association, where they showed results of this automated algorithm based on this deep neural network. They showed results which were comparable to those of the ophthalmologists, the human ophthalmologists. And so this work received, again, a lot of attention and praise by the medical community. So in fact, earlier this year, this paper from 2016 was rated amongst the 10 best papers of that journal in the last decade. So this is a very reputed journal, and it's a medical journal. So you can see the medical community recognizing, again, the power of AI, the power of deep learning to help with again, important medical problems. The other example I would give would be kind of on cardiovascular disease. So the basic idea is that now, and the reason I argue why a lot of action would be now for healthcare at home and at work when we are living our normal lives, is that now we can be actually monitored. Our various parameters, our various activities can be monitored through things like mobile phones that we all carry, the wearables, which are also becoming popular, and things like cameras, which could, again, be deployed right at home and so on, where through these sensors, you're able to track somebody's body vitals, things like their heart rate, respiration rate, and so on. The kind of activities, physical activities, is this person doing, getting enough exercise? What kind of food is this person eating? Are they smoking? Are their state of mind? Are they under a lot of stress? And things in the environment. So the idea is that after extracting out these kind of signals, for which again you probably in many cases need to apply AI again to those to the sensor output to get these signals. When you further analyze these signals, you can create disease risk model for various diseases and start to suggest timely interventions. So one concrete example of this, which we have started exploring, is to look at prevention of cardiovascular disease. So cardiovascular disease, which shows up, which leads to things like heart attacks, strokes, and so on, is actually the #1 killer of humans on the planet. And in India, an interesting kind of data point that was shared with me recently was that roughly 80% of the people who are dying of a heart attack or a stroke actually are not even aware that they have cardiovascular disease. So that's one. Second, people in India are dying of these heart attacks now at an increasingly even younger ages due to various kind of lifestyle factors and so on. And a lot of that can actually be either prevented completely or delayed significantly. So a cardiologist, Dr. Santosh, that we've been working with from JIPMER, he tells me that there is clearly a potential to add 10 to 15 years of healthy life to millions of people who end up having heart attacks or strokes through mostly things like very simple lifestyle modifications or very simple medical interventions. So as simple as saying, hey, please go and walk for at least 30 minutes, at least 5 times a week, or cut down on the amount of salt that you're consuming. You're eating too much of that bhujia and cut down on your salt content, or things like you need to quit smoking. So things like these lifestyle modifications or early simple medical interventions like keeping your blood pressure under check. If your blood pressure is not reduced by these lifestyle changes, then take medication, but keep it under check. Keep your blood sugar level under check. So through these simple interventions, somebody who observes them, they can actually delay an incident of something like a heart attack in many cases by at least 10 to 15 years. So all of that is good, right? But then some of you might be wondering, what about data privacy, right? So all of that is good, right? But then some of you might be wondering, what about data privacy, right? Because if you're really monitoring each person's kind of activity, their body vitals, and are they smoking or not, what are they eating, and so on, a lot of this is very private information, right? Sensitive information that a person may not want anybody else, right, to know. So again, there are technologies like federated learning, which we are looking to utilize for these kinds of analysis. And I'll kind of very quickly describe what federated learning is. So this is technique, many companies, many research groups, which are building upon this technique, right? Advancing this technique. So the idea here is that, let's say if I'm a user of a mobile phone, right? And my mobile phone is capturing some very sensitive data about me, right? What am I eating, my heart rate, respiration rate, and so on. Now, I may not want that data to be stored on a cloud, on any server, right? I may not want it stored on whatever, even a Google Cloud or something. So can you ensure that the data remains on the device, the raw data remains on the device, and still you're able to do all this machine learning, right, over that data? So federated learning, again, is a way in which you first kind of train these AI models. And as you might know, right, AI models need a lot of data to train. So you initially train these AI models on proxy data, and you distribute these AI models on each device. And then you have the locally run model on each device, essentially only work with the data that it sees on that device, and that raw data never leaves the device. But now, in order to make this AI model more accurate, right, over a period of time, you want to learn from the data of all these millions of users who might be, who are, let's say, using these mobile devices. So federated learning organizes all of that machine learning, right, in this federated style, in this distributed style, such that from these devices you share certain kind of parameters, but in a manner that you're not sending the raw data itself. And combined with techniques like differential privacy, which ensures that whatever model, machine learning model that you learn centrally, it is unable to track any individual data. It is unable to reconstruct any of that original raw data. So that combined with federated learning, right, can ensure that you still get some of those benefits from learning from all these millions of devices while fully preserving the privacy, the private data, right, of those individuals without kind of gaining, right, any kind of information, right, about that private data, specific data values, right, for that individual, who was smoking, who was eating what, and so on. So that kind of idea, right? I mean, hopefully that gives you some examples, right, of how AI can be applied to healthcare. Another initiative that we have is, again, applying AI for social good, where we work with various NGOs. So we organized a workshop last year, last November, very soon after our lab got started. And we asked these NGOs working in these areas of public health, wildlife conservation, education, what problems you are dealing with. And we looked at, again, can we apply AI to make a difference? And based on that, we selected some of these projects. So to give you a few examples, one of the NGOs we're working with is called Arman, which has this project called Mitra to improve maternal and child health. So what they do is they make a voice call, automated voice call, and deliver a message in that call to women who are expecting during their pregnancy. And it delivers for every week, there is like a message that provides advice, valuable advice to them, what to watch out for in that week, whatever particular, let's say, diet to eat, any kind of, let's say, nutritional supplements they should take, let's say iron tablets and so on. And they found that, yes, for these mothers who stick with this program, they have better outcomes. But the problem they had was that roughly 52%, so roughly 48% of the women actually drop out of this program. Roughly half of them don't kind of stick with this program. So they wanted to see if AI could be applied to identify who all are likely to drop out from that program, and so that you can then kind of engage with them and keep them engaged on this program. So together with IIT Madras, our team deployed this model and tested it on Armand data and found that you were able to predict close to 80% of these women who were likely to drop out. And now we are trying to see if we can actually keep them engaged based on this information and ensure better outcomes. Again, just a quick check. I hope I'm still audible.
Yes, sure.
Yeah. Then another project that we are doing is with Pratham Book Story Weaver on kind of translation of children's storybooks in different languages. And likewise, we are also working with NPTEL. So some of your engineering students might be familiar with the NPTEL program, where all these IIT professors have created these online videos covering various courses. So what happens is when you're trying to now translate all these lectures covering various courses. So what happens is when you're trying to now translate all these lectures from English to different Indian languages, one of the problems that NPTEL has encountered is that if you, for instance, have this particular sentence, let's start our course in machine learning and deep learning with Python. A literal Hindi translation will translate machine learning into kind of machine seekhne and Python into Ajgar. And that wasn't the intent, right? So here by Python, you don't mean the animal Python, but the programming language Python. So the literal translation kind of leads to very odd kind of output. So can you do this machine translation in a entity-aware manner? So that was kind of one example. Another NGO that we are working with collects a lot of data through manual forms. So can you do OCR, optical character recognition, right, over such these kinds of forms? Let me quickly kind of, I know we are kind of out of time. So how much time do I have? Should I guess we should leave some time for questions. Is it okay if I take should I take 5 more minutes?
Please don't worry, you can continue and you can take as much time as you wish. If you are not in a hurry, we are not.
Okay. So, okay, so maybe I'll take 5 or 10 minutes. So let me give some examples of how we are also improving Google products through the use of AI. And one piece of work, this is actually done by my colleagues in Israel, but we have started a collaboration with them, is around flooding. So we know, and in fact, right now, right, there are floods which are beginning to affect different parts of India. So this initiative is to produce high-resolution flood forecasts and warnings globally. And the work was started in India because India has kind of, again, some of the biggest problems related to floods globally. So the idea is to start with some physical measurements of water level of the river at specific points upstream, and then being able to predict that there is going to be flooding, right, over the next few days. And this is done through a combination of these two models, a hydrologic model and a hydraulic model. What the hydrologic model does is, given things like temperature, precipitation, and so on, it kind of predicts how much is going to be kind of the water level, right, in the river at a certain point in the future, right? So it does a kind of a prediction in time and space that for these points in the river, the water level after, let's say, 48 hours is going to be this much. So that's the hydraulic model. Hydrologic model. What hydraulic model does is, again, given these various levels of the river, it predicts the levels of water in the floodplain as kind of flooding happens. And what this team did from Google research is to actually build a machine learning based model for both hydrology as well as so hydrologic model as well as hydraulic model. And with that, they were able to achieve very high levels of accuracy. In fact, one of the issues that you run into with hydraulic model, so for hydraulic model, you need a lot of very detailed information about the digital elevation maps, right? How much for every point on the map, right? What's the elevation level, right, of that point? Because that governs, right, whether water is going to kind of accumulate at that point, or is that point going to be above the water level, right? So what happens is when you work with existing data that is available on digital elevation map, it tends to be very coarse-grained and often it's old. So the left part shows that kind of data that is available from sources like NASA, this SRTM data. It leads to, again, very, very coarse kind of prediction, right, which are shown on this left side. Whereas the goal is to do much more accurate prediction using fine-grained digital elevation maps. So one of the challenges that our team has been working on and helping the flood team is by applying analysis over things like satellite images to be able to come up with accurate maps of riverbeds and so on, so that the team is able to do a more accurate job of flood prediction. So the Google team has signed agreements with authorities in several countries. So they started with an agreement with Central Water Commission in India, and through this agreement we get access to various water level readings at different points along the river Ganga, and we have been then making predictions. And what is shown on the top part of this diagram, the top diagram, is the traditional methods, which are quite inaccurate. So there you can see that the parts which are shown in red, those were actual cases of flooding that got missed by the model. And the ones shown in purple are those which were false negatives, false positives, in the sense where the model said there's going to be flooding, but actually there wasn't flooding. So contrast the current model based on machine learning, where again, I mean, there are some false negatives and false positives, but for the most part, you see kind of it in blue, which is kind of where the model, the prediction is agreeing with actually what was observed. So we are getting now much more accurate predictions of flood forecast. Then the next challenge, of course, is to disseminate all this information. And there we are using things like Google Search, Google Maps, where in the maps we indicate locations which are likely to get flooded in the next, 24 or 48 hours. And Android, through which we send these notifications. And we are also working with kind of additional NGOs like Red Cross and so on, right, to disseminate information, and other NGOs. So kind of a generalization of this work, we have this team called Earth Observation Science, which is essentially developing and applying computer vision techniques to satellite images for various kinds of purposes. I had mentioned like automated riverbed extraction, but you can also imagine things like better water management. So India ends up consuming something like 80% of the fresh water is consumed in India for agriculture, and we consume far more water than most other countries for kind of similar amount of output. So can you help cut down on and in fact, India is staring at a water crisis coming down the road. So can we actually cut down on the water conservation, on water consumption, and actually save water? Again, switching gears, some more examples. We have, in addition to Google Search, that I'm sure every one of you must be using, Google also has now this assistant, the product called Assistant, which is a voice assistant. which is actually letting a person ask their queries in just simply by saying it to voice, and it will answer those questions. So the Google Assistant is right now shipping in 9 Indian languages. It has again millions of daily users, and as we see again this usage, we see again many challenges that need to be really overcome to make this assistant really useful to all these millions of people who are using it. And these relate to things like being able to handle the rich diversity of languages, dialects, and accents that we have. Things like code mixing. So often in India, we mix up multiple languages, right? So we might, and many of the users are first-time users of the mobile devices or internet. So they are not very familiar with how to formulate a query, right? So they may, instead of a single query that appears as a single question, they may almost think that they're talking to a human, and they may have like pauses in between their query, right? Somebody might say market mein, and then after a pause, tamatar ka kya bhav hai? And you are mixing up English and Hindi and various kind of things. So if you simply build a model that only understands English or only understands Hindi, it will not be able to do a good job. So you need multilingual models which are able to understand all this kind of input. So again, in the interest of time, I'm going to now kind of skip some of the rest of my talk. I'll just hopefully I've given you some examples that you find interesting of how AI technologies like AI can be applied to solve real problems that affect us all as humans. And what I would say is the stuff that I talked about, I mean, you can think of that as just the tip of the iceberg. There's so many more possibilities around how computing and AI could be applied to solve real problems. So I'd really like to encourage, especially the students in the audience, the younger people, so take advantage, right, of all of this compute power that you now have at your disposal, and apply again computing to solve real problems. So pick up problems that you're passionate about, that are of strong interest to you, and kind of spend the next 5 years of their life, right, making contributions towards solving that problem through the use of computing, through the use of AI, by kind of working with other domain experts who can help formulate these problems properly. And I would say there are so many exciting possibilities about how AI in the future can be applied to make this world a better place. And I look forward, and I hope some of you are motivated to learn more about AI, learn more about these techniques in AI, and then go and solve some of these problems. So I'd like to thank you all for your time, and I'm happy to take a few questions.
Well, thank you very much for such an illuminating lecture. And I'd like to invite Director Nehru Science Center, Mumbai, Kenneth sir, to begin the conversation. Sir, could you please come in?
No, I think Dr. Gupta rightly put up. I mean, the students are who are more important than us who played our innings. So I think there are several of them who are in attendance. Some good questions are also coming. So maybe one or two of these questions can be addressed by Dr. Gupta.
Yeah, sure.
There's one to Saloni Tripathi. How do you think the occurrence of pandemic in an area can be addressed, using this artificial intelligence?
Yeah.
Compared with past times.
Right. So if you're talking about COVID, I would say the honest answer is we have not done a very good job. I mean, had we applied again techniques based on AI to kind of studying some of these spread of epidemics further, right, and kind of in a more timely manner, I think we would have done as a world, right, a better job. But even so, I would say one of the ways in which AI is being used is to help accelerate the discovery of drugs and vaccine for the COVID. So normally, like developing a drug for a given whatever condition is usually like a 20-year process. I mean, traditionally has been like a 15 to 20-year process, right, in the pharmaceutical industry, where you start with candidate molecules and so on. So again, there's been a lot of speeding up of drug development with the use of technology, and even more recently, people have been applying, researchers have been showing how to apply AI to speed up the development of vaccine and drugs to treat the condition, because we badly need this to become available as soon as possible.
Another good question, I thought, because you're talking about known unknowns, there are unknown unknowns also. For example, there's, I think Rakshita Saxena has asked this question: what are the opportunities for artificial intelligence in the field of astronomy?
Right. So astronomy again, there's a lot of very, I mean, often if you look at, let's say, the data our telescopes are collecting, I mean, it's huge amounts of data, and in addition to humans, right? Because sometimes there could be, let's say, certain phenomena happening. Let's say there's a supernova explosion or something, right? So one way in which you could use AI is to have some of these AI systems actually identify certain important events instead of only relying on humans, right, to do that manually. The other way in which AI is being applied a lot in science is to accelerate scientific discovery. Because a lot of times the way scientists kind of study the world around us is through computer simulations. So you take laws of physics and you kind of simulate those laws of physics on supercomputers. And often what you find is, let's say you're trying to simulate the evolution of galaxies, let's say, by applying laws of physics. These simulations are often very, very computationally expensive. So it may take you years before you will really get any meaningful results out of those simulations. So in various fields, our researchers have shown that through the use of AI machine learning, often you can take some shortcuts. You can get to more accurate, to reasonably accurate results with a smaller amount of total computation. So AI is being used in a very significant way in assisting scientists with accelerating scientific discovery, where it is being used as, there's a term called the fourth paradigm, where in addition to the first two paradigms, right, which are theory and experimentation, high performance computing was often referred to as the third leg of scientific discovery, that through high performance computing you start simulating the world. Now through AI, which is now the fourth paradigm, through data, often you can speed up your analysis quite significantly, allowing you to get these results and make predictions, scientific predictions, for that same amount of compute power.
So the way there was questions about what are the scopes of AI in astronomy. Mr. Ashish Rai through our YouTube channel has asked a question: how do you envisage the scope of AI in the field of agriculture?
Sure.
How can it help the farmers?
So many ways. I mean, one of the important applications is helping farmers with, like, take care of pests and diseases, right, that affect their crop. Because there might be a particular pest that is attacking the crop, and the farmer may not fully understand, right, what's going on with their crop. So can you let the farmer just take a photograph of that plant and let an AI system, right, identify what disease is affecting that plant, and also provide some suitable advice, right, in terms of how to deal with that particular pest or that particular plant disease. So that's one example. There are many more. I mean, people are also looking, I mean, you can also do some of this analysis and aggregate. You can kind of do analysis of satellite images, identify like the kind of crops that are being grown and so on, right? And provide advice about the right choice of crops for a given region and so on. So, and we are actively beginning to talk to some of the domain experts from agriculture to understand what are some of the problems, right, where AI could be applied to make a difference.
I like one question, this catch the Meng is a buzzword. There's one Sandeep Kumar Ratneri, he's from NCR, Regional Institute of Education. He's asking, how do you introduce this concepts of artificial intelligence right at the primary school level, upper primary school?
So two things I would say. One is, if you look at kind of how we are conducting this particular webinar, right? I mean, it's all being done through online videos. So as more and more kind of teaching content, right, learning content is delivered, right, to students through videos. The previous startup that I did, that startup still is around, called VideoCan. What it does is it applies AI to analyze the contents of the videos to automatically create things like a table of contents, similar to a textbook. It will create a table of contents for that video. It will create a, similar to that index in the book, list of key concepts that have been covered in this video. And when you click on any of that, let's say table of content entries, let's say topic number 6, which is talking about AI for healthcare, it will directly take you to that point of the video where that topic is being covered. Because what happens is that when somebody gives you a 1-hour video to watch, nobody has the patience to watch that 1-hour video, right? If it was a movie, yes, we would watch it for 2 hours. Forget about 1 hour, you will watch it for 2 hours continuously. But if I give even a 30-minute video, I can guarantee you, most students, and myself included, I mean, I'm not saying this is for others, myself included, if I'm given a video to learn something, after a few minutes, the mind starts wandering. So if there is a nice table of contents, that tag cloud and so on, I'm able to visually see, okay, where is each topic of this video is being covered. And if I'm only interested in a given topic, directly jump to that part of the video. So that's one example. But the other major trend I would say is AI can help enable personalized learning. So especially when you ask about primary school level, right? What happens is you have different children, right, who may have different backgrounds and different kind of interests, different learning rates, right? So some people may be very good at math. Some people may be very good at languages. Now, today, our teaching style is very much like one size fits all, right? There's a teacher who's essentially teaching the class, the mathematics, right, at pretty much the same rate. So if an AI system can cater to, let's say, somebody who is a bit of a slow learner when it comes to math, but otherwise is very intelligent, the AI system can help this person, right, with cater to that student, right, in a more personalized manner, right? So maybe it can automatically, if the person, they find that while the person is going through the material, they're struggling, maybe it can provide more helpful hints and additional material on like prerequisite concepts and so on. Whereas somebody who's getting bored, somebody who's very proficient and is otherwise getting bored with that content, it can kind of give them more advanced material to learn. So this whole personalized approach to learning is something that can also be enabled through AI systems.
So on your presentation, there is a question that the elevation maps are usually dynamic and ongoing developments in several parts of the country will keep on affecting the predictions and results. So how do you deal with that? Is there collection of live online data all the time?
Absolutely. So that's a great question. So in fact, one of the problems has been that traditionally these online maps have been very old data, right? That could be 10 years old data and so on. And if you're talking about rivers, even rivers change course after a flood. Often, right? The river might change course a little bit, or there could be new construction, right, in a given region. So one way around that is through satellite imagery. I mean, because there are satellites which are kind of taking these images all the time in a continuous manner. If you're able to effectively analyze these satellite images, right, and come up with effective digital elevation maps, that is one way of a more scalable approach to doing this on a more ongoing basis.
There is another question that nowadays, these days, in many homes, we have children and sometimes elderly people who need special care, but the people are not around to help them probably in many cases. Can AI help in such situations?
Right. Again, I mean, there are, for instance, AI system. I mean, my prediction is a lot of healthcare, right, is going to be outside the hospital. So when people who require, let's say, critical care, I mean, an elderly person, right, who's suffering from a chronic disease, it's not feasible or nice, right, to just keep them confined to a hospital bed, right? So they need to be at their home. So can you have an AI system, right, monitor people and kind of help suggest timely intervention, right? So there are systems that can sometimes detect falls, right, that this person has fallen, or there are even systems that have been built that are trying to predict a fall, right, and kind of a variable that is then trying to cushion the impact of that fall. So again, there's a lot of innovation being done in terms of in the home setting, right, of how AI can monitor. I mean, and there's a lot of work that when I was leading the Xerox Research Center, we had a whole set of research projects on through cameras, can you infer all kinds of body vitals, the heart rate, respiration rate, and so on, right, of an individual, and can be able to detect conditions like arrhythmia and so on, right, and again suggest timely interventions. So I think there are things being done, and there's a potential to do a lot more.
So I have a question: is FPGA is going to be the next high-demand technology for artificial neural network-based application, which actually lost its vigor some years back?
So you're talking about FPGAs?
Yeah.
Yeah. So FPGAs, which is functional programmable gate arrays, right? So these are essentially configurable kind of hardware which can help you accelerate, right, certain kinds of computations. And what AI has actually triggered is this whole kind of almost like, again, a lot of advances in computer architecture itself. So there's a lot of, because AI has become the dominant workload, there is a lot of activity around using specialized architecture, right, to accelerate various kinds of AI workloads. So yes, so many people are using now FPGAs to accelerate certain kinds of AI computations. But again, FPGAs is not the only kind of hardware acceleration. People have been using GPUs, right, for that purpose. That's why companies like NVIDIA and so on, right, have really benefited a lot from the adoption of AI, that GPUs are being heavily used. Now, Google itself has created these specialized hardware for deep learning systems, which are called TPUs, tensor processing units, which are actually even faster than GPUs or FPGAs, right, when it comes to accelerating these deep learning kind of computations. So there's a lot of innovation being done in hardware. So FPGA certainly is one kind of one approach, one which is being used by many companies to accelerate AI workloads, but it's not the only one.
We've taken all the positive aspect of it. There is one beautiful question. I like this. Rakshita Saxena. He got She's talking about the drawbacks in terms of critical,
Oh, okay.
issues.
Actually, thanks for that question. That's a very, very important question. I mean, I kind of made some passing reference initially to talking about limitations of deep learning. It's very important for us to also recognize of the harm that, and in fact, for that reason, Google announced these 7 AI principles that we said we will abide by, and now every product, every research project now goes through audit, that are we complying with these principles, right? So what are some of these principles? One of them is around safety. So AI systems, I mean, let's say you have AI being applied to healthcare, and if you do really, really bad prediction, right? You can actually, even though these are only being used as decision aids to the doctors, if you tell the doctor, oh, I don't think there's any case of whatever, let's say cancer, right, in this particular image, the doctor might also get influenced, right, by that recommendation. And let's say you have a false negative, right? You have missed the actual tumor, right, in that image. So one example, so one aspect is simply safety. As AI gets used more and more in these very critical situations, you could make mistakes and put the lives of humans, right, at risk. Another big aspect is fairness. So one example I will give is, you will find now a lot of companies, including startups and other companies, offering these recruitment solutions today in India, right? Here's our AI-based recruitment solution, right, which will help you analyze the resumes automatically, right, and help you shortlist which candidates should you call for an interview, or analyze the interviews of your candidates and kind of help you shortlist candidates that you should select for that job. Now, there are numerous studies that have shown that if a human is making these decisions, because how do these AI systems, and let's say you have the best AI system, right, that has been trained by annotated data, right, on how to select these resumes. There are several studies which show that if you are looking for a high-tech job, a woman is at a serious disadvantage relative to a man. You keep every part of the resume the same, you simply change the name from a male to a female name, and suddenly your chances of getting selected will go down because of the biases that we humans carry. And if an AI system learns, again, because I mean, the way you train an AI system, right, is often through labeled data. So if I use all this labeled data, right, out of all these resumes that were selected by the HR teams, which resumes got selected, if I simply train my algorithm blindly based on that labeled training data, I will carry over the same biases that the humans carried, right? My AI algorithm will also start discriminating against women for these job selection for high-tech jobs. So how do you avoid these bias issues, right? How do you create fairer AI systems? That's another big challenge, and it's a very active area of research.
So probably we are towards almost the end of it, and thank you very much for giving us so much of time. One last question I'd like to ask, that in India, do you feel that where we always doubt that whether enough data is available and there is quality data availability? Do you think that applying AI in the faces a challenge therein regarding the quality of data availability here?
No, there's absolutely a challenge that we face because of quality of data and kind of availability of labeled data. But what I would kind of talk about is the potential, right? The potential is there, right? We can be a very, very data-rich country because we have so many people. We can generate more data than almost any other country, right? Other than China, and in many aspects, right? We can generate more data and high-quality data if we get our people behind some of these initiatives. But yes, as a practical matter today, because we are often not very well organized in terms of creating these data sets and so on, yes, it creates a challenge for applying AI. The other thing, but I would also mention is there is also a lot of research being done on improving AI techniques so that there is less of a dependence on all this labeled data. So that's also an active area of research.
And one last question to you, sir. Since we are into this profession of disseminating science and communicating science to not only to the students but also to the people who has to take probably educated guesses and informed decisions in many cases nowadays. Do you find any collaboration between your organization and our organization so that we can represent your researches much better to the people, and you can also extend some of your services to us as well?
Sure, that's a great point. I mean, we would love to have more such collaboration. Right now, a lot of our collaborations tend to be more around research, specific research topics that we pursue along with academia, right? So we have collaborations with, again, professors at Indian Institute of Science, various IITs, and so on. But your point is well taken. That yes, there's a lot more that can be done to kind of engage the community at large.
And is it possible, because we have a very large network of innovation hubs where just pass out engineering students are also members in many cases. Is it possible to build a repository of smaller projects that can be distributed through all these innovation hubs and what they can practice into?
Yeah, so there are various programs. I mean, I'm trying to remember the name of this Google India program. I think it's called Innovate for India, where actually we go out and we kind of invite students to kind of submit their entries where they are solving real problems through the use of technology, right? And then we kind of give out awards to some of the best entries and so on. So and likewise, I mean, so Google India has been running this particular challenge. I know, so I'm also associated with ACM, which is the Professional Society of Computer Scientists Association for Computing Machinery. So ACM India, again, 2 years ago, we ran, and we are looking to revive, kind of to modify that program a little bit, where we invited student chapters to work on innovations, on real world innovations, right? Fix some problem that they saw around themselves and apply computing, right, towards a solution to that problem. Yeah, so there are a number of such initiatives, and again, would love to see these scale a lot more.
I think on behalf of both the centers, Regional Science Center Calicut and Bhopal, and much larger National Council of Science Museum, which is about 25 science centers, it gives me really immense pleasure to really thank you so much for spending a lot of your time. And one thing is sure that this is a time when our young generation, especially those going into the serious sector, more than being a job seekers, perhaps your lecture opens out an eye to be a job provider and a job creators. So that's what I think. Thank you so very much, and looking forward to having you maybe once more. Thank you so much.
Thank you.
Thank you, sir. Thank you, sir.